Hi, question number 4 taken from June 2015 A-Level Maths Mechanics 1. A particle P moves in a straight line. At time t seconds after starting from rest at the point O on the line, the acceleration of P is a meters per second where a is equal to 0.075 t squared minus 1.5 t plus 5. Find an expression for the displacement of P from O in terms of t, and also find the time taken for P to return to the point O. Okay, now for the first part, we should remember that if this is acceleration, then velocity is going to be equal to integration of the acceleration. So therefore we're going to integrate and find velocity first. So you have to raise, when integrating this, okay, so minus 1.5 t plus 5, all with respect to t. So raise t to the power of 3 if it is power 2. Therefore you're going to divide this by 3 and you're going to end up with 0.025 t to the cube minus, raise this to the power of 2, 1.5 divided by 2 is 0.75 t raised to the power of 2 plus 5t. Okay, and at that point we know that k should be equal to 0. Velocity is 0 when time is equal to 0. Okay, the object is starting from rest. Okay, so if it starts from rest, v is equal to 0 when t is equal to 0. So now we need to find in the question the distance. Distance is s, integral of v dt. So we're going to integrate this whole expression here. So we're going to integrate 0.025 raised to the power of 3, this whole expression here. It's like a double integration. Raise this to the power of 4 and you divide 0.025 by 4, 0.00625. So this is going to be 0.00625 t raised to the power of 4 minus 0.75 divided by 3. You raise this to the power of 3. That's going to become 0.25 then, t to the cube, plus if you raise 1 to the power of 2, you divide 5 by 2, you're going to get 2.5 t squared. And again, the constant k is going to be equal to 0. There is no displacement when t is equal to 0. Remember, the object starts from rest. So this is an expression for the displacement. Okay. Now for the second part, hence find the time taken for P to return to the point O. Now when t returns to the point O, what happens is that displacement is going to be equal to 0, because the particle P returns to O, so as if there's no displacement. So what we're going to do, we're going to equate all of that to 0. So 0.00625 t to the 4 minus 0.25 t to the cube plus 2.5 t to the square is equal to 0. T squared is common, so we can put t squared outside. 0.00625 minus 0.25 t plus 2.5, and all of that's going to be equal to 0. So where can we go from here? 0.0625 minus 0.25 t plus 2.5 is equal to 0. We're going to be solving this by quadratic formula. So we're going to say then t is equal to minus, so it's going to become plus 0.25 plus or minus root of b squared, which is minus 0.25 to the square, minus 4 is 4 times 0.0625 times 2.5 divided by 2a, 2 times 0.00625. So t is going to be 0.25 plus or minus root of, so let's move on here, 0.25 to the square minus, in brackets, 4 times 0.00625 times 2.5. It's going to give us 0, isn't it? So therefore 0 divided by 2 times 0.00625, so that's going to be 0.0125. So we have then 0.25 divided by 0.0125, 20. Therefore the time it takes for P to return to O is 20 seconds. Here we are for the second part of this question. Hope you've enjoyed the video. This is taken from A-Level Maths HSC M1, June 2015.